Hello students, welcome back to Addition Fingertips. Today we are going to solve 9709 5 to MJ22. The paper is Probability and Statistics Part 1. Let's get started with the paper. Question number 1 says, for n values of the variable x, it is given that sigma x minus 200 is 446 and sigma x is 6846. Okay, we are supposed to find value of n. Okay, so we already know that sigma x is 6846, means summation of all the values is 6846, right? Now sigma x minus 200 means that from every value you have subtracted 200. Now how many times have you done that? You have done that n times, right? So minus 200n should give me 446. So from here I can say 6846 minus 446 is equals to 200n. 6846 minus 446, which is 6400 divided by 200. So my value of n is 32, right? Value of n is 32. Let's get to the second question. Okay, a fair six-sided die has the numbers 1, 2, 2, 3, 3, 3 on its faces. Okay, the die is rolled twice. The random variable x denotes the sum of the two numbers obtained. Okay, draw probability distribution table of x. So we have been given a die and we are supposed to roll it twice. So what could be the possible sum? Let's say I get 1 and 1. So the sum could be this is x, and let's say this is probability of x. Let's say the sum could be 2. Let's say if I have 1 and 2, so the sum will be 3. 2 and 2, so the sum will be 4. 2 and 3, so the sum will be 5, and 3 and 3, so the sum will be 6, right? So now let us find out first the probability of getting 2, right? Let us find out first the probability of getting 2. The probability of getting 2 will obviously going to be when you have 1 and 1, which is 1 by 6 into 1 by 6, 1 by 36. Now how can I get 2? I can get 2 if I have 1 and 2 and if I have 2 and 1. So the probability of getting 1 is 1 by 6. Probability of getting 2 is 2 by 6 whole multiplied with 2. So I think I have 4 by 36, right? 4 by 36. Okay, 1, 1 and okay. Now I have 4. How can I get 4? I can get 4 in 3 different scenarios. If I have 2, 2, if I have 1, 3, or if I have 3, 1, right? So probability of getting both the 2's is 2 by 6 into 2 by 6. Probability of getting 1 and 3, which is 1 by 6 into 3 by 6. This will be multiplied with 2 and I will have to add both this probability. So which is 4 by 36 plus 6 by 36. 4 by 36 plus 6 by 36, which is nothing but 10 by 36, right? Now how can we get 5? We can get 5, 2 and 3, right? So 2, 3 and 3, 2. The probability of getting 2 is 2 by 6 into 3 by 6 into 2. So 3 2s are 6, 6 2s are 12. So the total is 12 by 36. Now probability of 6 is obviously going to be, the total should be 1. So 4 plus 10 plus 12 plus 1 minus 36, which is 9 by 36. But you should also check your answers. This is one way to verify whether your answer is correct or not, right? How can I get 6? I can get 6 if I have 3 and 3. So the probability of getting 3 is 3 by 6 and one more 3 is 3 by 6. So 3 by 6 into 3 by 6 is 9 by 36, right? So it means what we have done is correct. Let us move to the next part. Find E of x and variance of x. Okay. So first we'll have to find E of x. E of x will be 2 into 3 by 2 into 1 by 36 plus 3 into 4 by 36, 3 into 4 by 36 plus 4 into 10 by 36 plus 5 into 12 by 36 and plus 6 into 9 by 36, right? Let me just make sure if I have taken the correct values or not. Yes, I have taken the correct values. So if you add all of this, I think you have 2 plus 4 3s are 12 plus 40, 12 5s are 60 and 9 6 are 54 upon 36. So let me add 2 plus 12 plus 40 plus 60 plus 54, which is 168 divided by 36, which is 14 by 3. So the mean is 14 by 3. Now I'm also supposed to find variance. How to find variance? Variance is nothing but 2 square into 1 by 36 plus 3 square into 4 by 36 plus 4 square into 10 by 36 plus 5 square into 12 by 36 plus 6 square into 9 by 36 and all of this minus square of mean, minus mean square. So I think you have 2 square is 4, right? 4 plus 3 square is 9, 9 4s are 36, 4 square is 16, 16 into 10, 160, 5 square is 25, 25 into 12 should be 300, yes. 6 square is 36, 36 into 9 is 324, 324 upon 36 minus 14 by 3 square. So 4 plus 36 plus 160 plus 300 plus 324, this is 824 upon 36 minus 14 square is 196 by 9. So let me do it. 824 upon 36 minus 196 by 9. So the variance is 10 by 9. The variance is 10 by 9, or you can say 1.11111 or 1.11. Let us move to the next question. The back-to-back stem and leaf diagram shows the diameter in centimeter of 19 cylindrical pipes produced by each of the two companies A and B. Okay. So the key is 135.3 means 0.351 centimeter from company B. Sorry, 0.351 from company A and 0.353 from company B. Okay, no issues. Find the median and interquartile range of the pipes produced by company A. So I'm supposed to find median. How many data do we have? I think we have 19 pipes, right? So median is going to be, obviously, the number of observations are odd, which means median is going to be 19 plus 1, which is 20th observation divided by 2. So the 10th observation of company A is going to be your median. So let us go to a 10th observation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So the median is going to be 0.355 centimeter. Right. Now I'm also supposed to find interquartile range. So for interquartile range, let me first find upper quartile and then find lower quartile. So the upper quartile is going to be median of the values from, I have to once again find the median of the values from this to this, right? So median of the upper quartile is nothing but 75th percentile. So leave the median aside and find median of the higher values. Same way, leave the median aside, once again find the median of the lower values, which is the values which are less than the median. Find median of those values and also find median of values which are higher than the median, right? So now I have, how many observations do I have? I think I have 1, 2, 3, 4, 5, 6, 7. sorry, 1 2 3 4 5 6 7 8 9 9 observations I have. So the median is going to be fifth observation, which is 1 2 3 4 5. So the upper quartile is upper quartile is 0.366 centimeter, and the lower quartile is going to be once again 5 observations. So 1 2 3 4 5. So the lower quartile is 0.348 centimeter, and thus my IQR is 0.366 minus 0.348, which is 0.018 centimeter. This is my IQR. Let us move to the next part. It is given that the pipes produced by material B have lower quartile, mid and upper quartile at so and so. Draw box and whisker plot. Okay, we are supposed to draw box and whisker plot for this diagram. I think it is pretty easy. We just found out the median upper quartile, lower quartile for company A. We have been given median upper quartile, lower quartile for company B. We also have the range, which is highest value and lowest value, highest value, lowest value. Just place them, and I think this is how your box and whisker plot will look like. See, I have started from 33, 34, 35, 36, 37, 38, 39. My lower one is company A and the upper one is company B, and the diameter is obviously in centimeter with the power of 10 raised to minus 2, right? 10 raised to minus 2 centimeter, because 34 means 0.034 centimeter, right? 0.34 centimeter. This was my box and whisker plot. Next, make a comparison between the diameters of the pipe produced by both the companies. Okay, so see, you can make multiple comparisons here. First, you can compare by median. You can say the median, meaning the diameter of pipes of company A is higher than those of company B, or you can say the variation or the range of diameter of pipe in company B is higher than that of company A, right? So let me just write down the diameter of pipes of company A is higher than company B. Diameter of pipes of company A is higher than company B. Next question. The weights in kg of a bag of rice produced by Anders have a normal distribution n 2.0302, 0.03 square. Okay. Find the probability that a randomly chosen bag of rice produced by Anders weighs between 1.98 and 2.03. Okay. So I think for that I'll have to find first Z1, which is x minus mu upon sigma, and Z2, which is x minus mu upon sigma, right? So let me just do this in calculator. I have 2.03 minus 2.02 divided by 0.03. I think this is 1 by 3, which is 0.333, and this is going to be 1.98 minus 2.02 divided by 0.03, which is minus 4 by 3. Okay, so Z2 is minus 1.333. So now I'm supposed to find the probability between 1.08 and 2.02. So let's say this is my normal distribution table or the graph. So this is my Z1, which is at 0.333. My Z2 is minus 1.333. I am supposed to find the region between this, right? So how can I do that? It is very easy. Let me first find the probability of Z1, right? Z1, and subtract it from Z2. So we'll have the middle region. So which is nothing but probability of 0.333 minus probability of minus 133. So probability of Z1 minus probability of Z2. So Z1 is 0.333. Let me find out its probability. Probability is 0.333. So probability of 0.333 0.333, 0.3, 3 is 0.6293, and 3 is add 11. So if I add 11, this is going to be 0.6304. 0.6293 plus 11 is 0.6304. So the value of Z1 is 0.6304. From this, I'll have to subtract. Right now, we have Z2 minus 1.33. But guys, we already know minus 1.33, right? And we are supposed to find probability of Z less than minus 1.33. But we already know that normal distribution table does not give us negative value. So what do? We flip the graph. So if I flip it, this minus 1.3 will go over here, and we'll find out the region which is on the right hand side, right? But I'll have to subtract 1 from it. Why? Because the normal distribution table always gives you the value of less than region. So let me find the probability of 1.333. So I have 1.33, which is 0.982 plus 3. So 0.908, 1.33, and I have 3, which is 5. So 0.9087, 0.9087, 0.9087. So let me do the subtraction. 0.66304 minus 1 plus 0.9087, which is 0.5391, 0.5391, or I can also write it as 0.539. Let us move to the next part of the question. Okay, the weights of bag of rice produced by binders are normal distributed with mean 2.55 and standard deviation sigma. Okay, in a random sample of 5,000 of these bags, 134 weighed more than 2.6 grams. So probability that they weigh more than 2.6 gram is 134 upon 5,000, which is 134 upon 5,000, 0.0268. Okay, I'm supposed to find the value of sigma. So you already know, guys, Z is equals to X, which is, I think, 2.6 minus mu upon sigma. I'm supposed to find sigma. But I already know that the probability of weighing more than 2.6 is, see, 2.55 is my mean. So 2.6 is obviously going to be on the right hand side of 2.55. Let's say this is 2.66. So the probability of weighing more than 2.66 is this region. This region is 0.0268. So I'll have to find out Z. So what will I do? I'll subtract 1 from here. 1 minus 0.0268. 1 minus 0.0268, which is 0.9732. And I'll find out the value of Z, for which the probability is 0.9732. So probability of 9732. Probability of 9732. Let me just go here. Where do I get probability of 9732? 97. Oh, I think I have exact value, which is 9732. This is 1.9 and 3, 1.93. So we already know that the value of Z is 1.93. Value of Z is 1.93. So I'll write 1.93 is equals to 2.6 minus 2.55 upon sigma. Sigma is 2.6 minus 2.55 upon 1.93. So 2.6 minus 2.55 upon 1.93. So the value of sigma is 0.0259. The value of sigma is 0.0259. Let us move to the next question. Question number 5. In a large college, 28% of the students do not play any musical instrument. Okay. 52% play exactly one musical instrument and the remainder play two or more musical instrument. Okay, so the remainder is 52 plus 28 is I think 80. The remainder becomes 20%. Okay. A random sample of 12 students are chosen from the college. Find the probability that more than 9 of the students play at least one musical instrument. More than 9 meaning that either 10 or 11 or 12 will play at least one musical instrument, right? At least one musical instrument. So how many of, see, 52 play 52 play exactly one, 20 play more than two instruments. So in total we have 72% who play at least more than one instrument. Okay, so and we have taken sample of 12 students. So by using the formula of binomial theorem, 12C 10, probability of success which is 0.72 power 10 and failure which is 0.28 power 2 plus 10 not 10 plus 12C 11, probability of success power 11 and probability of failure power 12 plus 12C 12, 0.72 power 12 and 0.28 power 0. So let us solve this. So 12C 10 into 0.72 power 10 to 0.28 power 2 plus 12C 11 into 0.72 power 11 into 0.28 plus 12C 12 is I think 1. So 0.72 power 12 and this is power 0. Okay, so the final answer is 0.3037, which is 0.304. Let us move to the next part of the question. A random sample of 90 students from the college is now chosen. Use an approximation to find out the probability that fewer than 40 students play exactly one instrument. Okay, fewer than 40 meaning 39, 38, 37, 36. Now this is not possible, right? This would take a lot of time. So what do? We solve such kind of binomial distribution question with the help of normal distribution, right? How do we do that? For normal distribution, we need mean and sigma. Mean is mu, which is n into p. Sigma square is n into p into q. N is number of trials. We have taken 90 students. Exactly one musical instrument. I think the probability of students playing exactly one musical instrument is 52%. If I'm not wrong. Yes, 52%. So, okay. So you have n, which is 90 into 0.52 and sigma square is 90 into 52 into 0.48, right? So my 90 into 0.52, mean is 46.8 and sigma square is 0.48, 22.464. I am supposed to find fewer than 40, right? Fewer than 40 meaning probability of x less than 40. So the value of z is 39.5, right? Why? Because for less than you subtract 0.5. So 39.5 minus mu upon sigma, which is under root 22.464. So 39.5 minus 46.8 divided by root of 22.464, which is z minus 1.540. So I'll once again have to find out probability of less than minus 1.4540, right? So let's say this is my graph and I'm supposed to find out less than, meaning this region. So we already know, guys, that normal distribution again cannot give us negative values. So what do? We flip the graph, right? And this value will now become our 1.54, and we'll find this right hand side region, right? Let me use the table of normal distribution for 1.540. Okay, so I think 1.54 will do. 1.5 and 4, 0.9382, 0.9382, right? So the probability is 1 minus 0.9382. Why 1 minus? Because this is going to give me the left hand side region. 1 minus 0.9382 is 0.0618. The final answer is 0.0618. Let us move to the next question. Question 6a. Find the number of different arrangements of the 9 letters in the word crocodile. Okay, so I think this can be easily arranged by 9 factorial. Divided by, we have 2c and 2o. So we have 9 factorial divided by 4, which is 90720. Next, find the number of different arrangements of the 9 letters in the word crocodile in which C is at each end and the 2 O's are not together. Okay, so first let me do one thing. C is at each end. C, R, O, C, O, D, I, L and C. So let's say C is at each end. So now we have 7 letters. So this can be arranged in 7 factorial divided by 2 factorial ways, right? This is the total number of arrangement. Now what do we want? We want the O's to not be together. So what I can do is, let me bring O's together. Let's say, let me bring both the O's together. So now this O will act as a single unit. 1, 2, 3, 4, 5, 6, 7 and 8th letter and 9th letter. So now this can be arranged in 1, 2, 3, 4, 5, 6 in 6 factorial ways. So the final answer is 7 factorial upon 2 factorial minus 6 factorial. So 7 factorial upon 2 minus 6 factorial. Sorry guys, just made a mistake. 7 factorial upon 2 minus 6 factorial. 1800 ways. Right. I have next question. It states that 4 letters are selected from the 9 letters in the crocodile. Okay. Find the number of different selections in which C is not same as the number of O's. So I think C is not same as O. Let's say I have 1 C and no O. Let's say I have 2 C and no O. Let's say I have 2 C and 1 O. In the same way I can go, let's say I have 1 O, no C, 2 O's and no C, 2 O's and 1 C, right? Now this can be arranged in, I think I have left out C, O, O and C. So 1, 2, 3, 4, 5. I have 5 letters. So this can be arranged in 5C3. This is 5C2. 5C1, 5C3, 5C2, 5C1. So 5C3 into 2. 5C3 into 2 is 20. 5C2 into 2, which is again 20. And 5C1 is 5. And 5 into 2 is 10. So total we have 50 ways in which we can arrange this selections. Next part D. Find the number of ways in which the 9 letters in the word crocodile can be divided into 3 groups, each containing 3 letters. If the 2 C's must be in a different group. So we are supposed to divide this into 3 groups. Right. So what is the method of doing this? Let me first find out the total number of ways in which I can divide into 3 groups. So I think I have, for the first group, the total letters are 9 and I can have 3 letters in the first group. So 9C3, In the same way, second group has 6 letters left. So 6C3. Now this will have 3C3. Right. Now guys, this is selection. So the order does not matter. So I'll have to divide it with 2 by 2 because we have 2C. And I also have 2O. And I am supposed to divide it into 3 different parts. So divide by 3. So the final answer is going to be 9C3 into 6C3 divided by 3 2s are 6, 6 2s are 8. Sorry, 6 2s are 12. So which is 140. Right, this is the total number of A's. But we want that the 2 C's must be in different groups. So let me do one thing. Let me club those C's together. Let's say I have 2C, 1 2 3 and 1 2 3. Right. Now let's say I have 2 C's. Right. Let's say I have O here. So now obviously one more O is going to be placed in any of this group. So let's say I have O here. So now I am left with 5 letters. So this is going to be 5C1. Sorry, not 5C1. This is going to be 5C2 into 3C3. 5C2 is, sorry guys, 5C3 into 5C2 into 3C3. This is 10. Right. Let's say I have C here and both the O's in any of the one group. So here I have 5C1, here I have 4C1 and here I have 3C3. Because why 5C1? Because obviously, see, you have the word crocodile, you have eliminated 2C and 2O. So now you are left with only 5 letters. So 5C1. Here, as I have already selected one letter, so I am left with 4 letters. So 4C1 and now 3C3. So 5C1 is 5, 4C1 is 4. So 5 4s are 20. Now is there any combination left? I think yes. If I divide O's into different groups. So now here I have 5C1 into 4C2. So 5C1 is 5. 4C2, if I am not wrong, is 6. So 5 into 6 is 30. Right. So what is the total possibilities? 30 plus 20 plus 10, which is 60. Right. This is when both the C's are together. But I want C's into different groups. So the final answer is going to be 140 minus 60, which is 80. 80 is your final answer. Let us move to the next question. Hannah buys 12 hollow chocolate eggs that each contain a sweet. The eggs look identical, but Hannah knows that 3 contains a red sweet, 4 contains an orange sweet, and 5 contains a yellow sweet. Each of the Hannah's 3 children in turn randomly chooses and each one of the eggs, keeping the sweet it contains. Okay. Find the probability that all the 3 eggs chosen contains the same colored sweet. Okay. So I have, I think, 12 eggs in total. Out of them, 3 contains a red sweet, 4 contains an orange, and 5 contains a yellow sweet. Okay. So all the 3 eggs chosen contain the same sweet, which means red, 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 or yellow, 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 or orange, orange, orange. So probability of getting all 3 red is 3 by 12 into 2 by 11 into 1 by 10. Right. By 11 because I have selected one sweet, so I have one less sweet than the regular. So here I have 5 by 12 into 4 by 11 into 3 by 10. The same way I have orange, I have I think 4 sweets. So 4 by 12 into 3 by 11 into 2 by 10. Now let me find this. So this is going to be 12 into 11 into 10 is nothing but 1320. So the denominator is going to be 1320. I'm supposed to add all the numerators. 3 into 2, 6 plus 5 4s are 20, 20 3s are 60, 4 3s are 12, 12 2s are 24. So 60 plus 20, 60 plus 24 plus 6 divided by 1320, which is 3 by 44. So the final answer is 3 by 44. Let us move to the part B of this question. Part B. Find the probability that all 3x chosen contains a yellow sweet given that all 3 children have the same color sweet. So now we know that all the 3 children have same color sweet, which is 3 by 44. And out of those, how many of them will have all 3 as yellow? So I think all 3 as yellow is nothing but, I think 5 4s are 20, 23s are 60, 60 by 1320. The probability is 60 by 1320. So 60 by 1320 divided by 3 by 44. Let me do this in my calculator. 60 by 1320 divided by 3 by 44 is 2 by 3. Okay. So the answer is 2 by 3. Okay. So next question. Part C. Find the probability that at least one of the henna's 3 children chooses an egg that contains 3 orange sweets. So I think we have the sweets are arranged as 3, 4, 5, red, orange and yellow. 3 red, 4 orange and 5 yellow sweets. So at least one of the 3 children chooses an egg that contains an orange sweet. So at least 1 orange, 2 orange or even 3 orange would work. So let me do one thing. Let me find the probability that none of the sweets are orange. No orange, no orange, no orange. Let me subtract 1 from it. So I think I'll have at least one value where I have at least 1 orange sweet. So no orange means the sweet should be either red or yellow, which is 8 by 12 into 7 by 11 into 6 by 10. And I'll have to subtract 1 from this. So let me do the calculation. 8 by 12 into 7 by 11 into 6 by 10. And 1 minus answer is 41 by 55. So the final answer is 41 by 55. I think with this, yes, we are done with the paper. Hope you have enjoyed. Kindly like, share and subscribe to our channel. Have a great day. Bye bye.